I felt for your presentation that was much more prepared. We've run through it like 5 times, so I think we're good.
Yeah, we should be good.
Just so long as this works.
Yeah, we checked beforehand.
Don't
Should
let
be
us
loud
down.
enough.
Don't let us down, Alexa. I guess I'm going first.
Got 2 minutes to run to the bathroom.
Is it possible to have it on both screens, or do you want it both sides? Hey Jay, how do I duplicate screen instead of splitting screen?
You want to exactly do it?
Yeah, I want to see. Ready? How's everyone doing today? This is our final presentation. I'm Dan.
Kadir?
Jay. We're Team VSync. Our sponsors are Cinecore, sitting over there, those lovely people. Quick introduction of what we're going to be going through with you guys today. We're going to be giving you a summary of the project. We're going to go over the high-level features. Then we're going to get into some high-level system architecture, some machine learning and why we needed it, as well as some SDK problems that we faced. And then we're going to jump into a retrospective and finally future goals for the project. So what was the problem presented to us by Cinecore? So they came to us and they had a bunch of visual web portals. So they had a bunch of visual user experiences, but they wanted to supplement the visual experience with a voice user interface. A voice user interface is basically anything where you can use your voice to communicate and interact with a user experience. So in our case, we went with an Alexa skill using the Amazon Echo Dots and their infrastructure. We also talked about doing things like using the Google Home, etc. The main motivation for creating this new voice experience was that it's a lot easier to do certain things with voice instead of visual. And one of those examples was one of the key aspects to this project was doing account management stuff with the skill. The main reason for this is currently if somebody loses their password or they don't remember their email, Cinecore is being hit with a bunch of callers to their call centers, basically asking those simple questions like, help me recover my account. With a skill, it's just a simple, Alexa, what's my password, or reset my password, what's my account name, and you can have all that information at your fingertips. A lot easier than trying to browse around on a website trying to find things.
So going into the high-level system features, as Daniel has mentioned, there's the obvious account management ones with getting username, getting email, or resetting of the password. And then there's the personalized newsreader, which is a little bit of an upgrade from what we showed last time. The newsreader itself exists. You can get articles. It's also more geared towards the specific user using some ML on the back end so that the user experience is a little bit more personalized in that regard. So going into a quick demo of these features with the username, email, and password first in account management, you'll notice that here that we're saying CableCo as opposed to Cinecore because Cinecore usually creates these products for their clients where they'll be using the skills. So Alexa, open CableCo.
Welcome to Cable Company. With this skill, you can reset your password, get your username or email, and ask for the latest news. What would you like me to do?
Get username.
The username for the current account is KXA8968. Is there anything else I can help you with today?
Get email.
The email for the current account is kxa8968@rit.edu. Is there anything else I can help you with today?
Reset my password.
You are about to send a password reset request. Are you sure you wish to proceed?
Yes.
A password reset link has been sent to kxa8968@rit.edu. Please check your email for further instructions. Back to main menu. You can reset your password, get your username or
Alexa.
email, and ask for the latest news. What would you like me to do?
Okay, thanks. So I'll just show a quick look at that email that I just got sent. Here's the password reset email, and you can see the link here. You follow the link, and it'll bring you to CableCo's reset password page. It's a little bit easier to reset a password on a web portal as opposed to doing it by voice, so you don't have to A, say the password, and B, this is the API that was easiest to work with for us, what was given to us. So back into the presentation, we can move on into the next set of features. So this is the news reading features. Basically getting articles, you can have it read the title, the summary, and email you the article, and you can also do this with more categorized news, giving it the parameters of sports, entertainment, or financial. So Alexa, open CableCo.
Welcome to Cable Company. With this skill, you can reset your password, get your username or email.
Get news.
I have retrieved 30 articles. I will read the title of each article. After each title, you may ask me to read the title again, read the summary, email the full article, or continue to the next article. Say next or read the title when you would like me to begin.
Read the title.
The title of this article is The Latest, Thomas Unsure How He Became PGA's Big Hitter. What would you like to do?
Email me the article.
The full article about The Latest, Thomas Unsure How He Became PGA's Big Hitter has been sent to your inbox. What would you like to do?
Stop.
Is there anything else I can help you with today?
Get me financial news.
I have retrieved 30 articles. I will read the title of each article. After each title, you may ask me to read the title again, read the summary, email the full article, or continue to the next article. Say next or read the title when you would like me to begin.
Read the title.
The title of this article is GOP Congressman from New York Charged with Insider Trading. What would you like to do?
Summary.
The summary of the article is Republican U.S. Representative Chris Collins of New York has been indicted on securities fraud charges. What would you like to do?
Stop.
Is there anything else I can help you with today?
No.
Thank you for using Cable Company.
So that's a quick run through of that, and I'm going to have to show you one of the other emails because the emails may take a little bit to send sometimes. So you can see any pictures that will come with the article will be shown at the top, and then you can read through the full text of the article here. So that's a quick overview of the features. One thing to quickly note, the 30 articles that it does grab, that's a number that we chose because it felt like a good number of articles so that the user wouldn't be endlessly going on with articles. This way they have some kind of stop. So that was the number that we chose when we were going with that.
All right, so here's our overall system architecture. And when we're creating Alexa skills, it has rigid skill structures that we must follow. And here we go. So first, user says requests, such as reset my password, get my username. Once that happens, Echo takes that data into the Alexa voice service. Once the voice service takes that audio data, turns it into the characters in computer languages, and then also authenticates the user and sends it over to the AWS Lambda, which is a serverless computer system that Amazon provides us. And once that code is delivered to the Lambda, then Lambda runs our project code to work with Alexa Skills Kit and several other APIs we have. Then once that is all executed, then the AWS Lambda takes that data back to Alexa voice service into a response JSON format. Once that happens, then Echo knows what to speak and gets us what we want to listen.
So to dive in a little bit more into the machine learning work we did on the project, we decided to use machine learning because we needed to personalize the news reading that you just got demoed. And besides that, though, we really don't think it was possible for us to have or do all the calculations that we needed to do in the skill itself because of resource concerns. Then for potential approaches, we did a lot of research into different ways we could use machine learning in the different algorithms out there. We really only scratched the surface of it, but what we decided to go with is Tf-Idf. And Tf-Idf is term frequency inverse document frequency. What that does is it calculates or assigns a score to each keyword for each news article. And you get a higher score when there are several of the same keyword for each user, and a lower score when there are multiple keywords across users. And then some of the takeaways for machine learning. The data set we had to create to use machine learning was pretty straightforward because Tf-Idf requires just simple strings of characters to score. And then another takeaway was not all implementations are created equal. So the first attempt at implementing Tf-Idf was done with a library that performed very poorly in testing. So we had to go back to the drawing board, do a little bit more research on different libraries that we could leverage to increase the performance, and we ended up finding one that does meet the expected load. And then finally, testing resources. So there's two different code bases, obviously the skill and then the machine learning code itself that need to be testing. And unfortunately, we were testing with the same database, so people were trying to use the same database while needing to test different code in the database. So it became a problem, and it was another speed bump in the road.
A quick overview of kind of the overall structure of the machine learning. This subsystem basically has three key layers with three main subsystems running within it. Over here on the left, we basically have one subsystem. In the middle, we have another one, and then way over on the right, this is the third subsystem that we're using. And essentially, what will happen when basically how this works is when a user reads an article either through email or they read the summary of it, we're going to basically get those keywords from the article and we're going to push it into the database, and then the database is going to have a store of all the keywords that the user has ever read or ever basically liked. The indication to us that they've liked it is that they've read it or they've emailed it to themselves. Then over here on the far right, we have the machine learning code itself. What this is going to do is it's going to pull all of those keywords out of the database. It's going to run some calculations way up here, and then it's going to calculate the scores for each user and post them back into one of our database tables. And then the final step that's going to happen here is that in the middle here is when a user then next time goes to get their news. The user is going to pull the data from the database. It's going to get the scores for each keyword, and then we're going to send queries to APIs with the keywords that have the highest scores. So essentially what's happening is user posts keyword data when they read articles, we calculate the scores, and then we use those scores via Cinecore APIs to get the keywords that we want. So the Skills Kit SDK. So this was a huge speed bump for us, and the reason we wanted to talk about it a little bit here was because of the challenges that it posed for us. The Alexa, about February, March time, Amazon released the version 2 of their Alexa SDK, and we were previously started the project using version 1, and they were so vastly different in their structure that we had to basically overhaul our entire project over the course of the next few months to basically meet these new requirements. The main reason that we decided to actually upgrade in the first place was because it had a number of key bug fixes and a number of key features that we needed. The main bug that it actually solved was we have two states between the account management side of things and the news side of things. And the way Alexa handles those states is it basically does it internally for us. But there was an actual bug in version 1 that was causing the states to not be able to be cleared. So we'd basically enter the news state, we'd read some news, and then there was no way to go back to resetting my password or anything like that. So the main reason we had to do this upgrade was because of that bug fix there. And we're going to go into some of the problems associated with this upgrade in a little bit, but I don't want to take away from Jay, so.
Alright, so here's our project retrospective. So what went well? We pretty much did nearly production-ready Alexa skill. That's the best part we've done, because it passes everything, every our unit test we've written, integration tests, and performance tests as well. So the only thing it's not ready for production is because Amazon needs to approve this, and we haven't really submitted this yet. So that's the next step. And the second thing I want to mention we did well was the many new software domains. We've done so many new softwares and worked with it, such as virtual machines, web service, APIs, Alexa SDK, Amazon Web Service, etc. You name it. We've learned a lot of things, and that's what we think we did pretty good. Moving on, what did not go well? Yes, it's a tough thing to talk about. However, we've done we've picked out both integration and performance testing as the thing that we didn't really do well, because it took the building Alexa skill took a lot more of a layers to test, because it requires to run underneath AWS Lambda and so on. And the next thing we did bad about performance is because we did it very late at the project. So when we ran the performance test, we figured all this execution time problems and all that stuff too late at the time. So we had to do a lot of our code redundant, and what I meant is redo it, whole process again. And next thing would be the learning curves on many new software. As I mentioned, we can name all these softwares: Jenkins, AWS Lambda, PostgreSQL, PHP, all that stuff. That just took so much time for us to take it off and catch within it. Next thing I want to talk about is Alexa SDK V2 upgrade, because it was a lot of pain. It just simply had to, we just had to rewrite a lot of code because it was just super long. I'm going to show you this. This is our version 1 code. It's that short, and this is our version 2 code, which does exactly same thing, and it's pretty much double the length. So our future goals are recommendation engine, push notification, and build ping features. First of all, recommendation engine is already very, very close because we already have a machine learning data. So all we need to do is just implement another logics and we just need more time to do that, and maybe next team can pick it up. Second thing, push notification is unfortunately not capable right now because Amazon does not support it. However, they claim to support it by next year, 2019. So cross our fingers for that. And lastly, the bill ping feature. Bill ping feature would be awesome to have. However, we do not have, we might need another external credit card related API and law related consults, all that stuff. So that would be our next step to work on. Questions? Yes?
So how strict is the phrase recognition? Do you have to say get news, or you can say something like give me the news or read the news?
Yes. Go
So
ahead.
with the Alexa, the conversion from speech to text with the Alexa, there's a thing called an intent schema where you can list a number of utterances. They're basically phrases that you can say to trigger a certain command or intent in that system. So if we notice that a lot of phrases are being said but not picked up, we could add them to the list of utterances that users would expect to be there for a certain intent. And then once we build that model, the skill should be able to handle that in the future. In terms of how strict it is, generally, if you don't have like a heavy accent, she'll usually understand the words that you're saying and pick them up correctly.
You definitely have to be careful though, because we ran into issues where we have the account management get my email, and we also have email me this article, and those are two separate intents. So we had to be really careful not to mix those utterances, because otherwise you could accidentally trigger the wrong one. So that was definitely something we actually encountered at one point, and it was a bug we had to fix.
Yep. Any next question?
Could you describe in a little more depth how you get from running a Lambda to calling the machine learning software?
Oh, so pretty much I can handle that. So a Lambda, let's go back to the, no, not that one. You're talking about this one, right?
Yeah, sure.
Yeah. So Lambda is where our code lives. All our project is underneath Lambda. It has a zip file that has all our code. So once Echo deals with the Alexa voice service, it generates a request JSON and sends it over to the AWS Lambda. And once that request JSON goes to Lambda, then it pretty much just invokes our code. It's kind of like our object is alive in this server.
I get the Lambda sense that the hardware touches the...
So to add on to that a little bit, the Lambda itself will be calling some separate APIs, those PHP scripts. They're actually living on our VM right now. We didn't want to clutter this diagram with too much, so it exists outside of this.
Yeah. But, go ahead.
So yeah, just to quickly maybe make even more sense, hopefully, is this PHP layer here is all on our virtual machine. This is basically just an API. So everything with PHP next to it is basically what's interacting with the database and what's handling the machine learning code. And then everything with JavaScript is what's in the Lambda. So only this part is actually in our Lambda, and everything else exists outside of the Lambda.
Right.
Okay. Any other questions? Cool.
So I just want to be clear that Tf-Idf is actually not the machine learning algorithm. It's just to calculate how important the word to document the collection of the costs. So it's basically counting some kind of percentage. It's not learning.
It could be seen like that, but it's definitely
It's just a different approach.
Yeah, it's just
There's
different.
It made the most
names
sense for
and
us, but
stuff.
we're just trying to find the importance of words for
Mhm.
the future.
Mostly calculating.
What's that?
It's mostly calculating things rather than learning things.
Machine.
Yeah, it learns over time. We have a certain threshold that we require in order for the system to learn. Like, we don't want to score keywords unless there's a fair amount of data in the database until we actually do that, so.
I think what you
it's
might
not
be
that way.
referring to is that supervised learning and unsupervised learning in machine learning.
No, it's just a calculation. So if you're going, it's come from information retrieval, not from machine learning. So you calculate how important the words relative to the documents, right? Yes, basically that. So you just get the number. It doesn't train the data and apply the model to predicting the data. So it's not machine learning.
We didn't put the Tf-Idf like architecture or description that we went over in terms of machine learning, but things like documents are, it's a term in the machine learning field.
So
but
documents
for
is
each,
becoming everything, right?
but
Let's
So
not
you don't
mince
want to-
words here.
But-
I don't want to argue with that.
that's okay. It's just a terminology thing, I think.
Right.
The initial intent too was to create a recommendation engine that will recommend articles to users, and that uses a lot more like deep learning and stuff. So we sort of,
You don't need to.
yeah, okay, sorry.
All right, let's thank the team.
Okay. Good afternoon, everyone. We are Team Pterodactyl. We created the tax-efficient retirement income system, or as we refer to it, TERI. Our faculty advisor was Professor Reichenmeyer, and our industry sponsor was Beltziani and Associates, who were represented by Stephen Howes and Mark Seiler. My name is Hunter Kasky.
I'm Matthew Manser. I'm Neil Sound.
All right, so let's get into it. So a little bit about our problem background. So many Americans don't engage in adequate retirement planning activities, and that leaves them in a vulnerable situation for having a very unstable financial situation when they enter retirement. So this instability arises from a lot of different unknowns and risks associated with retirement planning in general. So a lot of people aren't comfortable with dealing with these issues. So it would be great if there were software products available that kind of just dealt with this retirement planning decision making for them. And there are a couple different tools out on the market right now, but a lot of them make faulty assumptions about the economy and the US tax code, which actually ends up producing suboptimal results for saving for retirement and spending during retirement. So Beltziani and Associates tasked us with creating a web application called TERI, which is a retirement planning tool. And TERI exceeds in this realm because it's highly customizable in terms of the amount of different strategies that we offer financial advisors to choose from in terms of saving and spending. And it also takes into account a lot of different pitfalls that taxpayers kind of run into when they're planning for their own retirements. So without further ado, we're going to show you a bit about what TERI is about and how financial advisors can use this to outline a good, secure, and prosperous financial plan for their clients. So here we have the initial view page of TERI. This is just the client list that has all of the different records that are currently stored in the database. So we're going to dive right in and choose Mr. and Mrs. Final for demonstration purposes. So we have a few different panes here. Up at the top is more of like the client and personal information portion of it. So in client details, we have information about the filing status of the client. So our system supports single and married tax filers, their desired income, and inflation rates. That's just like market predictions that they're comfortable making. And then under personal details, it has the individual information for each person in the actual client. So this is just for the husband in this scenario. It lists like his birthday, retirement, age, how long he'll be in retirement, and values such as like his pension and social security distribution, as well as his salary. Below all of that, we have the listing of all the accounts. So in Terry, we have 4 different types of accounts that we currently support. These are 401ks, traditional IRAs, Roth IRAs, and non-qualified accounts. So we have an example of 401ks, Roths, and non-qualified right here. So each account has some common fields associated with it, such as like a name, principal, things like that. And then if we look at creating a new account, so we can specify type, and these types are actually pretty important because each of these different types of accounts have specialized tax treatments under the federal tax code. So if, for example, if we chose a 401k, it has additional fields like employer contribution, because these types of accounts are like negotiated between individuals and their employers for saving for retirement. So let's cancel out of that and quickly view the settings page on the left here. This is an overview of all the different tax code system configuration values that Terry uses to predict taxation and things like that. So here we have the tax bracket threshold values and the percentage that income is taxed at. Below the, so single to married, and below that we have like capital gains tax information, standard deductions, contribution limits, just standard configuration things come to the system. So if we go back into clients, select the Mr. and Mrs. Final again, and then go into projections. You see, this is kind of like the meat and potatoes of what Terry is all about. So we have a very detailed plan for how the client and the individuals within the client profile would save for their retirement. And it extends out until the end of their retirement, so it also specifies how they should spend their money once both are retired. So up at the top here, we have savings algorithm and spending algorithms that you can select from. So you can choose different savings and spending algorithms based off of the different ones that are programmed into the system. So for savings, they're more ordered around how you prioritize your contributions to your retirement savings. And our spending algorithms are kind of focused on how we can hover around different break points in the tax code to prioritize spending and retirement. So below that, we have this giant table that kind of lists all of the account details and client information for each year from the start date, so 2018, out until the end of retirement. This specific client goes like until 2090 or something like that. So for each different account, we have an ending principal, starting principal, growth, contribution, withdrawal. So we can get pretty granular information about what your assets will look like each year. And then at the bottom here, we have them all totaled up. So you can get a quick overview of what a client's profile looks like for a particular year. And then at the bottom, we have some extra information that's also relevant, like your salary, combined salaries in the form of earned income, social security, pension, desired income, and then tax information. So Matt's going to take over and show you a bit about the graphical interpretations of these numbers.
So in this chart, you can first see the income breakdown of this client. So this client is a married couple. They're both working in these first years with this blue section, and they're earning more than they need to satisfy their lifestyle. But then, one of them retires, leaving them with a severely reduced income where the difference is covered by their 401ks with withdrawal of Social Security and their pension. Then, as a second family member, or the second member of the couple retires, it switches entirely over these alternative methods of funding. But, as you can see, in approximately 2069, they run out of money. They don't have enough money to meet their increasing expenses as inflation takes hold. And then in 2070, they're left with only their Social Security. So in their tax breakdown, you can see that they pay most of their taxes in the early portion of their retirement, or working years of retirement, and that's on income and 401k withdrawals, which are also treated as income. But then it cuts off sharply and becomes almost nothing as they start taking most of their money from their non-qualified accounts, which are your money market accounts or your other interest load-bearing stock accounts, and their Roth account, which offers no, or for which they pay no taxes at all. So if this were to be smoothed out, they could get out of these higher tax brackets and pay less money throughout their retirement. So under their account details, you can see the breakdown of their assets throughout both pre and post-retirement. They start off with a good mix, but as they convert money and use it, they end up with primarily Roth money at the end, which they use all the way up until that 2069 date when they run out. But through a simple change in their accounting strategies, they suddenly have enough money to make it all the way to the end of their retirement and have a little nest egg to give about $200,000 to give to their heirs. So this breaks into the major features of the system, and the one too that we added in this in our term of project. Or presentation. So we added primarily Roth conversions and RMDs. RMDs, or required minimum distributions, are rules where the federal government requires you to take a certain percentage of your qualified money, which is your pre-tax money, out every year after you turn 70. And this percentage increases as time goes on and can push you into a higher tax bracket, so you're paying more money in taxes and leaves you with less to complete your retirement. So this person is not converting any money in the Roth account, and you can see that it grows under its interest, but remains a small proportion of the final balance of their assets on death. But if they were to Roth convert, you can see that the Roth account becomes a much larger portion of their assets, and as Roth accounts are treated favorably under the tax code on inheritance, their heirs will end up with more money after their retirement ends, after they die.
So the application is built with React frontend, Java backend, and the SQL database. So the presentation here is the React frontend, and it interacts with the API of the web services. So it has the code API for the settings page that you saw previously for the text values, and it works with the projection system that works with the spending and the savings algorithm. So the domain layer has a tax engine and most of the logic, and it interacts with the data access object with the database, and it has the configuration files to store all of the tax rules values that you saw in the setting. It was originally in the initialization of the backend, but we abstracted that out, so it's easier to just go into the XML file and edit that.
Okay, so we're going to talk a little bit about the technical challenges and the solutions that we came up to get around those. So first and foremost is, so this was an inherited project. I think there were 2 previous iterations of Terry before we came across it, and we inherited a large code base, but unfortunately it was undocumented, and just the lack of understanding within the code caused a bit of technical debt for us. So that kind of delayed our starting work on the project. So our solution around that was, excuse me. So as we learned more about the tax code and like what the actual logic in the code base was doing, we decided where appropriate, we would refactor and redesign certain aspects just to make it more sensible and maintainable for future, and so that we had a better understanding of our own code base as well. Coupled with that is a pretty complex application domain. So the world of taxes, financial planning, and financial advising in general has like a lot of jargon and terminology that we weren't familiar with. So being neophyte to the subject, we kind of had a big learning curve to overcome. So we had to identify distinctions between things like qualified and non-qualified accounts, and how RMDs and Roth conversions can significantly impact a client's wealth over their lifespan. So just trying to understand these core concepts was pretty tricky for us. So we gradually documented all of these key terms and the meaning behind them into our domain and SRS and domain model and SRS and things like that. So it was just easier for us and hopefully future teams to get along with learning the domain faster. Also, nobody on the team had React coming into the project. So React is the technology that's used to implement the front end. Fortunately for us, the previous team did a pretty good job of making a functional front end, so we didn't have to do too many changes to them. But there were a couple of different times where we had to go in for new feature requests, and changing the way that the API worked on the server side also resulted in some changes on the front end, so we had to learn a bit of React for that. And that was just an investment in time that we had to make for the project. Because we have a smaller team size, what we did when we had to accommodate multiple feature requests is we broke up the work. So one person would take on the lead development majority for that. And this worked for the most part all right, but it caused some problems later in the iterations when we tried to merge and integrate all of our changes together. So naturally, a few integration bugs and merge conflicts came about that, and that kind of slowed us down a bit at the end of our iterations too. So our results, or our solution to get around that was just frequent communication. Our smaller team size made it so that we could share knowledge and communicate more easily and schedule more meetings. So that was kind of like an upside to that situation that we were in. And finally, we had some issues with the behavior of our savings and spending algorithms as they're modeled in their strategy subsystem. So the way that the code was set up was, when we took a look at it, is there was a lot of different variation of what was going on between these strategies. So we were noticing that some of the behavior was missing or a bit erratic compared to other similar strategies that were used in the retirement plan. So how we kind of cope with that is we tried to abstract that system as best as possible to minimize the redundant repeated code. And then we incorporated a template method at the top level so that we kind of enforced all of these subclasses of that to follow a strict pre-processing step, a strict post-processing step, and we left the actual execution of the algorithm up to that concrete subclass.
So as Hunter mentioned, we didn't have much documentation. There were some diagrams included in the previous team's iterations. So we started out just documenting our code base, our personal codes, and then we kind of expanded to the rest of the code base. And we decided to create a formal software requirements specification document. Basically, what we wanted to achieve was that we wanted to know that we were understanding the domain well enough that we could build us the proper software. And we wanted the sponsor to have that confidence that we were actually understanding what the domain, what it was supposed to represent in the code base. So we created some diagrams: the domain model, the system design model, the data model, and architecture model. This was for our benefit and the future team's benefit. So when they do come in, they can have various resources to kind of get started without having to struggle as much as we did. So, and we created a project README to kind of help with the project infrastructure and how to set it up without, having to dive too deeply into the code itself, so they could get everything started as quickly as possible.
So for future work, there is some rework to be done, especially in the coupling between the data model and the other major subsystems. There's a bit too much coupling there, and that makes it hard to that'll make it a little bit harder to maintain in the future than we would like. And as for new features, the raw conversions right now are a bit naive in their determination of whether and how much to convert, and it would be much better if they could have a more nuanced view of how a person's finances affects whether or not they should convert money from their qualified accounts to their Roth accounts. This could save them a significant amount of money, but for now it's a good starting implementation to work off of going into the future. There are also a number of special tax rules regarding specialized accounts, such as the health savings account, which its own rules would necessitate more implementation of its particular way of being dealt with as far as planning for retirement. And for the additional, another additional tax rule, which is for the Roth phase-outs, which are limits on how much money a person making a certain amount of income can contribute to their Roth account, which are also not implemented as of right now, but have some major ramifications in how much a person can put away in that tax-free Roth account. And of course, the state income taxes, which are not modeled right now, but are going to be needed for accuracy in the future. So these together are something of a roadmap for any future work that would be done on this project.
All right, any questions? Yeah.
Tax law changes a lot.
Yeah.
What skills do you have to have and what do you make changes to accommodate new laws every year?
So we just had a tax law change, so we kind of had to deal with that as one of our first starting points for this project. One thing that we saw in the project was, or in the code base, was there was a lot of hard-coded values that represented like the tax code, the concrete values for those. So we abstracted all those out into more configurable files. But I mean, besides from that, we follow a straight up like a progressive calculation of taxes. And we had this conversation with our sponsors before, like how well do we need to adapt to changing behavior in the tax law rather than changing like configuration values. And we decided it was best to leave that alone for now. And if needed, future teams would take on that responsibility. But for now, the current state handles calculating federal taxes pretty well.
The numbers, the numbers especially work in these human editable configuration files, because that lets someone without technical experience update them as long as they know where they are in the structure of the property file. So that does help, but it doesn't mitigate the problem entirely because there could be sweeping overhauls as we saw last year.
Does that answer your question?
Yes.
Okay. And yes.
How much time did you spend creating the full requirement specification? Did you think that it was worth as much time as you could? You got enough out of it? And was there a lot of pressure from your team coach to do it in such a formal way?
So it took about 2.5 weeks to put together, and we do feel we got a good deal of value out of it because it made more concrete what we were expected to do and what needed to be done for the system, or what needed to be implemented for the system to be considered done for our section. There wasn't very much pressure from our sponsor, or our faculty coach to do it. We more or less spontaneously decided to do it when we realized that we were working at somewhat cross purposes and needed a clear direction of what we were going to do for going forward.
Did you have to deal with any kind of security concerns when you were working on this, or was that kind of hard?
So that was something that was brought up, I think, like in one of the first or maybe the second meeting about it being a web app. But the sponsor's need was specifically that they would be running it on a local computer, and that was it. So there's no like third-party access to this. It would just be something that a financial advisor would sit down and use as an executable jar file on their computer. So we didn't have any internet connections going in and out of this. So security wasn't too big of an issue that we had to deal with for this project. Yes?
How did you ensure that all those calculations are actually correct?
We spent a lot of time sanity checking. So that was something that we kind of, as we added fixed bugs and added new features, our sponsor was able to actually use some of the commercial tools that they had available at their firm to kind of give us a sample data of what the numbers should look like way out into the future. So we kind of compared our results against them. And there's a bit of variation because we were trying to optimize in a different way. But that allowed us to kind of see a baseline in terms of how well we're calculating taxes, calculating count projections, including inflation into the variables, all those types of things. So we were able to use a baseline for that.
The goal, too, is not 100% accuracy. It's to give a picture of what the best general way to allocate resources is for that client. Because the specifics are going to change on a year-to-year basis. But if we have it's to give a general idea of the path going forward for that retiree, or would-be retiree.
Let's thank the team.
All right, thank you.
All right, we are the recruiters. My name's Aiden.
I'm Ryan.
I'm Nick.
I'm Jan.
And we're here to talk about Recruiter, which is a cross-platform job matching app that we created for our sponsor, Jim Bondi, on behalf of the Office of Career Services and Cooperative Education. And our team coach was Dan Krutz. So first we're going to talk about a little bit of a background, then we're going to just jump right into the demo. Then we're going to summarize kind of the big chunks of work that we did over the past 7 months, go into the design and why we made those changes in particular, technical background, and then reflect on our experience. So background and domain. So our main problem context is with the job application process. Coming from Jim, from our own reflections, from a survey that we conducted early on in the semester, and likely as you've all experienced, there can be some things that increase the speediness and kind of just overall pleasantness of the existing job application process. So we found that it was high cost, low visibility, low relevance, and low yield. You spend a lot of time creating that first deliverable that you send to this like black void and try and you get a lot of time, you wait a lot of time to hear anything back. And often, yeah, you're not really sure what's going on. So the proposed solution, so Jim, along with some of his colleagues, came up with this idea to kind of break the process up from that one giant deliverable into a series of smaller pieces. So phases is what he called them. That allows us to kind of essentialize the information that we show at each point to whoever's seeing it at that point in time. And it also allows the student to get kind of feedback on where they are in the pipeline. He also wanted to incentivize the speed. So instead of it taking weeks or months in order to finally to hear back at all or get the position, we wanted it to happen over a very short period. So we implemented this idea of job expiration. So all these job postings are only available for up to 10 business days. The other thing is we wanted to automate wherever possible. Often you're looking for really repeatable criteria, and we can put that right into the programmatic system. So important note, we were handed this as a prototype or the second iteration of this project. It was kind of a thin slice of the end-to-end process. It had a really Spartan UI. So our tasks were to productionalize it, to improve the usability and workflow of the application, kind of simplify it a little bit, enhance the matching system and its customization, and create an admin portal to allow us to validate companies. So we made sure that we had good data getting into our system, get it on the app stores, and then add an API integration as well. So we'll go through the demo really shortly, really soon after this, but just to give a basic introduction to it. So we are going to have two users. They're already going to be registered. The job recruiter will come from an already validated company with an already existing job posting. The student will see it, and we'll go through those phases as we described. The first phase is the problem phase, just going to be kind of demonstrating shared experience. The second one's going to be kind of putting your best foot forward for the job or for the student as well, and then the final phase. So let's get right into it.
So we're going to be running this, showing the two different halves here. The student will be on the actual phone. It is running on a phone. We're just kind of running a screencasting right now. And then the recruiter will be in the left here, and Aiden will handle that. So if I log right in as a student, we can see that we have a couple matches here right away. And funny enough, the job expiration that he mentioned, this number all the way at the top right there with a 1, and it's red right now because this job's about to expire, and earlier it was at 2, so it's, it is counting down to incentivize that speed to get this done quickly and apply now before it expires. And despite this being kind of a poor match, this percentage right here is a match strength, so it's a 51% match strength, but this is shown first because it's about to expire. So we wanted to make sure that they could get to this before it goes away. So this isn't a very good match, so we'll just decline it. So we can see the next one in the list right away here. We have a front-end developer job, and this one's much better, 98% match. We have all these little check marks here showing specifically what pieces of data we matched on. So we had New York City as a preferred location, social media as an industry, etc. So maybe we're more interested in this one, so we will continue the process. And the first part here, as Aiden mentioned in these phases, we have the problems phase first. So we read the company's problem statement. That kind of gives us an idea of what kind of stuff they deal with day to day, what work is involved. And if we're interested in that, we can continue and now provide our own. So this is where this back and forth process goes here. We provide our own problem statement to them. So if students or recruiters are confused about what something is at any point, we have these information icons throughout the application to kind of explain it, because at times it can be sort of complex. So now we provide our own problem statement, and we could add a new one, but we allow you to save things if
to your account, so for sake of brevity, we'll just choose one and approve. So now we just approved that. We were shown the next one on the list, but let's hop over to the recruiter side of things and take a look. Here's all the jobs that they have. This is only happening because there we go.
Display.
Yeah, we
resolution.
did test on different screen sizes. It's just when we're blowing up to this, it like janks everything. So, so now we see the matches for this job in particular, and we see in the first phase here, this presentation phase, what the student just submitted. So we can read the similar stuff. We see again it's 98% match. If we're not interested in the student just from this, we can decline right away, but 98% match is pretty good. Let's read a bit more, and there's that problem statement that we just submitted in the previous phase. So again, same process back and forth. We think that this sounds good, we like the work that the student's doing, so let's approve them. And similarly, if we go over to the presentation phase here, we now see that this company shows up in the next phase. So this is the first point that we actually get to see that this is Facebook. Our sponsor wanted to keep that first phase sort of shrouded as to what the company is to remove any potential biases. So now we get to see it's Facebook, and now it's their chance to present things to us. They get to show us videos and links that Facebook wants us to see. So we can tap over and take a look at these videos that Facebook wants us to see. We can take a look at whatever website they want us to see, stuff like that. And if we're interested at this point, again, this sounds cool. Same back and forth process here to maintain that consistency. We can add new presentation links of our own to provide video links or website links ourselves. So we'll select a YouTube video of our own that's saved to our profile and our personal website, and we will submit it. So again, sorry, I messed it up. So if we pull a refresh, now we see it showing up on the presentation phase here. So on the recruiter side, the presentation phase, they get to see the things that we submitted. They have their own links, etc. And again, we'll just approve it for the sake of time. And we see that it shows up in these final phases for both right away. And this is the last phase here. You've reached the end, and now the recruiter and the student can see these final matches. They can take a look and see contact information to contact each other. We can even go through and review the match, all of the steps that we looked at before, everything that was submitted, all the presentation links, everything there in case we want to look at it again. And even things like job archiving and shortcuts for sliding right here to be able to call or email, stuff like that works. So if we call it, sometimes it takes a little while, but it should call the phone number right away because we have it set. So stuff like that, nice little shortcuts connected up for students. So that's the main flow. For time's sake, we're not going to go into a lot of this other stuff, but we do have these flyout menus on both sides with managing all of your skills, job preferences, saving these presentation links and stuff that I mentioned to your account, all sorts of other things. So if you have questions about that, you can ask at the end. Cool.
So now we're going to go into a summary of all the completed work that we did. So there's a big evolution in the UI and the UX of the application. On the left here we have the inherited project, so this is what the application looked like when we first got it, and on the right is what it currently looks like. So basically we wanted a refined focus on the information that's being shown. So the information that we're being shown for matches is a bit different now, and we wanted to show the information that we thought was most important for students and recruiters. We have an overall better look and feel, we think. It's a bit more appealing and easier to look at. We also have better readability. We try to section up the information and help you to understand what exactly you're looking at and where to find things. We also have some improved user affordances. We've added just images and larger buttons, things just to help you understand what everything in the app does and where you should be looking for certain features. And we have clear calls to action. For example, on the left image, this is what the inherited project looked like. You would get a list of matches like this, and you would have to select them, and then use the buttons at the bottom to say if you wanted to accept or decline that match. We thought that was a little confusing, so right now on the right you can see you're just presented with one match at a time, and you have the buttons to either approve or deny that match. We thought it was just a little confusing with the
the way the previous was set up, having to select a match and then use the buttons at the bottom. We also added some enhancements to the matching system. So we expanded the matchable data that we have. Now we're storing all structured data in the databases for each match. And we're storing more data for each match so that we can refer to that later. Before it was just making the match and wouldn't store any of the data for what you're matched on. The system is also set up to implement scheduled updates from API. It's going to be pulling from Portfolium, which if you don't know is a bit like Handshake, where you can have a profile, add skills and work experience to your profile, just like Handshake. So it's set up to pull trending skills from there and add it to our database weekly, so that you can then add those skills to your own profile on Recruiter. And also, we have increased customization, so students can select how important certain preferences are for them. So you have preferences like locations and industries, so you can select the weight of those and determine how important those are to you in generating matches. And also for recruiters, they can change match thresholds, so they can choose to get more matches or better, higher quality matches based on what they want. And as for management features, we have recruiter management. So whenever a recruiter creates a company in the system, they are the primary recruiter for that company, and they can add or delete recruiters that can then add jobs to the system under that company. And as you can see on the left screenshot, that's basically the Manage Recruiter section when you're logged in as a primary recruiter. And we also provide a process for validating companies, so you can't just add a company and start making jobs. You have to be approved first. So we have an admin portal that you can log into and then see some of their information and then either approve or deny. And the admin portal is using the same code base as the other parts of the project. Basically, we were using Ionic as a technology, and that allowed us to just display different pages to you based on the user you were logged in as. So when you log in as an admin, you're shown this page. So on the left, those are the companies that need to be either approved or denied, and some of the information on the right. So then admins can log in, review some of this, and then approve them so that they can start making jobs in the system. We also wanted to productionalize the app. So right now we have the server in the database hosted on AWS, and we've been testing it on Android phones because we have it in the Google Play Store and downloadable for us for internal testing. So we've been using phones to actually update the server in the database that's hosted in AWS. We also have an iOS account prepared so that whenever we're fully ready to deploy the app, it can be put on the App Store and downloadable on iPhones. And as you see, this is just some of the AWS and the Google Play Store.
Cool. So now just some of the system design decisions. This being an existing project before, some of this was decided for us, of course. But those decisions were pretty standard, things like client-server separation, client agnostic, so the server doesn't know what client's connecting, it doesn't need to, just sitting as a standalone API. Things like using an ORM on the server side to avoid having to deal with a lot of nitty-gritty SQL commands and stuff ourselves, that's all handled. And then hybrid apps over native apps, that's a huge one, because there was an incentive with this project for cross-platform support, and switching to hybrid over native allowed us to just have one code base and not have to do these two separate pipelines of development for these very different platforms. And then some design decisions that we made, Nick mentioned the switch to Ionic as one of them. The project started in Xamarin. A lot of us weren't familiar with Xamarin, but also with the admin portal that we mentioned, we wanted to maintain this one code base, and Xamarin wouldn't allow us to really export the application for web browsers, really. So Ionic is just built with Angular. We're able to use that same exact application for web browsers and mobile. Also, the addition of using parallel streams, and a lot of the more modern Java 8 features, allowed us to use concurrency where possible to improve the matching, incentivize speed there, whereas before all of that was done in batch. So doing concurrently here, we were able to speed up that process. And then also normalizing match weights. With all these different filters in the system now, besides just required skills, which is what the existing application was matching on, all these new things, the weights didn't add up to 100, of course, but we still wanted to make these match scores make sense to people, so it was within that 0 to 100% range. So we had to normalize all of these match scores down so it was within that range. So that was a decision that affected things. So these trade-offs there was some complexity added into the system with our decision to have this one code base, because of course any stylistic changes you're making are often affecting it everywhere. So if you want to just change one thing for the admin panel, you have to do a little bit more intricacies in order to have it just affect the admin panel and not the other parts of the system. Also with hybrid apps, as opposed to native apps, we things like making one change again could affect the other. Make a change for iOS, it could affect Android, etc. And then also not standardizing our client views. We went with a page-by-page approach rather than abstracting our pages, and that's because we wanted to incentivize readability over code duplication. So if somebody were to come back, they would see, okay, this is the job creation page, this makes sense, rather than having to go through this complex structure.
So this is our architecture, and on the right is the client, on the left is the server. And if you notice, there's the difference between the old and the new systems. We wanted to make it more robust through the spring, and so we worked on that over the whole semester. The client side here is, again, you can see, we do use the phone to access everything, and that's how we have it with all these different components. The students, recruiters, companies, and whatnot. So you can ask, or you can send a request to the server using these components here. And then on the server, the HTTP, yep, hold on one second, yeah. We're using the Spring and Hibernate for those requests, so the server will route the request to the specific components based on the URL and the endpoint. There are lots of different controllers, such as the students, recruiters, and matches within the companies.
So our reflection then, so what went well with this project? We did find that consistent feedback and using mock-ups and everything and having these consistent meetings with our sponsor definitely helped us a lot. We made mock-ups for everything that we were doing, presented them at one point, got feedback from our sponsor, and then we're able to kind of tweak the implementation for our demos in the next week. And that flow really worked out well for us, and the mock-ups helped in a lot of other areas for implementation and style guides and everything as well. That switch to Xamarin, or that switch from Xamarin to Ionic that we mentioned, that was also good for us. We did it in the first place because we thought it would save us a lot of time, and it definitely did. It allowed us to include more features in that we weren't, originally with Xamarin going to be able to do. Another thing we did well was have a shared Postman account and do some of this shared testing stuff there. So whenever things were being worked on, server side at least, with the Postman account, endpoints would be added there and could be tested there, and we could all see them quickly without any delay there. And then also working more flexibly with iterations. I kind of mentioned that with the 2 weeks there, but we did have 2 weeks iterations, and that helped us big time to kind of be flexible in what we were doing at times, because we did have to adapt because, of course, we're all busy.
So these are some of the things that we thought we could have improved on a bit. We wish we'd been able to expand the problem statement phase a little bit. With talking with people about the app, we thought it might be a little confusing about what exactly the problem statement phase is and what its the intention is. So we wish we'd expanded on it just a little bit. We also wish we spent more time on group design and architecture, because for some changes we would just hop right in and start making changes to the code, and we wish we'd reflect a little more on the design and architecture and how we were going to be affecting it. And also investing in more granular tests for better visibility, because we ran into some issues in areas that would have been solved much quicker and easier if we had more of a focus on the testing that we were doing.
Well, the general lessons learned, the biggest one was just trust and evidence, encourage speed and flexibility. As we went on further along with the projects, we got a really good relationship with our sponsor and a much greater familiarity with the code base. And just having that ability to just maintain and keep adding on to something we already knew, we ended up being able to go a lot faster in the summer term as opposed to the semester. The other thing was just discussing and updating priority, being flexible with changing those between need to implement it now or for this deadline versus maybe it could be a later thing or kind of middle term. And then just demonstrating and explaining our rationale for the desired changes. It was really important for us to be able to communicate especially for the Xamarin transition, our rationale for doing so and what we thought it could get us. And then also for changing the presentation phase, we made some edits there, kind of demonstrating that this is something that the students didn't quite understand from our survey. That helped a lot. Any questions?
So, a couple questions about like what's next for the app. Have you guys first off thought about how you would market it to potential employees and employers, and then thought about how it would scale once you have a bunch of users, etc.?
Sure. Yeah, so it was done for the Office of Co-op and Career Services. So that was, they kind of had the idea originally of doing it in anticipation of the career fairs. So instead of having to go through that like 45-person line at the career fair in front of the Google table, you just have everyone kind of send out an email. You can register for this just like you register for Handshake, and then kind of get into the app and kind of do this for a few days leading up to it. And then you kind of just get to that endpoint. Anyone who's in that endpoint can schedule the interviews from there. You get to skip a line. That was a big use case. They have a lot of other projects that they're working on, other co-op groups, and a lot of really cool ideas with having like VR interviews and all of those types of things, different endpoints where we could kind of feed the final phase into. So they would do a lot of the marketing, and a lot of the usage would come first from RIT and then kind of go to other colleges, kind of like what happened with Facebook, really, I guess. And as far as scalability, we do have our stuff hosted on AWS. We do try to parallelize whoever we could, the bigger jobs. So we think it could scale. We haven't done any performance testing yet. We wanted to, but there just wasn't time for it. We had other priorities that superseded it, I should say.
And we did think about that to some extent at times with how we're doing the matching with the parallel streams a little bit, but we did have plans to change the matching even further to kind of only generate them as they're needed rather than do more at once. Yeah. And also the existing project is using MariaDB. Something that we propose to do eventually is use Postgres instead. So things like that.
The prototype you were handed, did the workflows change at all from like the back and forth employer to applicant interaction at all, or was that given to you in the prototype?
A lot of that you actually go.
Yeah, a lot of the flow there was similar, but there were some key things that we did change. For instance, we mentioned the presentation phase in particular. Before that was required to be a video, you had to submit a video every time, but we found that people didn't really feel comfortable with doing that or didn't want to make a video themselves every time. So we shifted that into this presentation idea instead, where you can add any links that you want, so you don't have to add a video, but if you want, that option is still there. Stuff like that. And then changing that initial phase as well, that first problem phase. It was initially that long match list. If you saw that picture that they had that list of matches, then the problem phase, then presentation, then final. We kind of combined, we essentially removed that long list and combined it into the problem phase. So we're just showing you that one match card, and that is the problem phase, because we kind of wanted to make it a little quicker.
A question on that. So how accommodating were your responses to those changes? Were they proposed by them, or were the team was like, we want to do this, and you brought them to the sponsor, and then you worked on that?
Yeah,
I think most of them were brought up by us, and it was mostly driven by interviews and like just talking with other students and people because they were confused about some things or really wouldn't want to use like certain features of the app, we thought. So we thought we presented some of those ideas, and which the sponsor agreed with, and we ended up changing them.
Jim was really good with the back and forth, and he kind of gave us some other ideas on how to kind of tweak things here and there. But the bigger changes that we discussed, those are the ones that we kind of try to come up with and push through. And he was really great and receptive to that, especially when we described them and the reasons to support. Yeah.
So I know that changing technologies all of a sudden it might be a little bit hectic, so it's a big decision. So what made you change from, I forgot what its name is, Ionic?
Xamarin. Yeah.
What advantages?
Luckily, there was very little upfront cost to switching to Xamarin. Because basically we just got rid of all their code and just created a completely new database. New code base. So there was very little like transition time. We did before, obviously, to better prepare for our explanation for why we wanted to switch. We all tried to get into learning a little bit of Xamarin, so we didn't full on just like we're going to do our own thing. But there were a lot of reasons. One was just our familiarity with it. We figured that we could start very much sooner, because we didn't have to learn a new code base. We could just start fresh with the technology we all knew. So we'd be faster with it. We'd be quicker to start. And the bigger one really was just that we already had a server code base and a client code base, and we weren't quite sure how to create or if it was possible to create web portal seamlessly integrated between the two, and we knew that's something that we needed for the admin portal, and we thought maybe recruiters wouldn't want to be on their phones at work. So maybe in the future, someone would want to create a recruiter web UI as opposed to a phone UI. So being able to have that flexibility from the phone as well as the web portal was the biggest reason we decided to switch.
All right, let's thank the team.
Okay, let's start by introducing ourselves. My name is Fawaz Al-Hnaki.
I'm Brian Young.
I'm Kasim.
I'm Doug Gahn.
And we're Team Bitforce. Our sponsor is AJ Grell, and our advisor is Professor Al.
All right, so in outline of our presentation, we'll go over the problem presented to us by the sponsor. We'll go over our goals, what our goals were for this project, a high-level description of the project, and the final product as it was delivered to the sponsor, and then finally a demo. So our sponsor was GE Industrial. They make industrial networking equipment such as this router I have here. Typically this would be connected out in a field somewhere, possibly to some sort of device, and this device here would connect to a pump or something and forward the control and information on that device to some central location.
So the basic problem that was presented to us by GE was when you're adding a device to a network, there are two things that you'll typically want to do. One is set the initial configuration of the device, and the other is give the device security certificates so that other devices across the network know that it's safe to communicate with. And currently, when you're trying to do these two things, you actually have to manually basically take a laptop, plug into the device, and go through your configuration setup. That's okay if you're doing a small number of devices, but if you have networks that are scaling up to 1,000 or more devices, it can get pretty time consuming to individually plug into each one.
So these are the goals and requirements that we came up with to address our scope. Basically, the main goal was to automate initial configuration of devices. So for this, we had to be able to add devices to our system. We had to be able to group devices by different attributes. Also be able to upload templates that we use to create configuration files. In addition, we also needed parameters, which acted as placeholders in the templates. And also be able to set up a SCEP server for device enrollment so that the devices, once connected, they can talk to the SCEP server to retrieve their certificate. Additionally, we had to generate templates and we had to generate configuration files using templates and parameters automatically. And we had to also be able to send configuration files to devices once they were certified and ready.
So this is a higher level architecture of our design. You can see that we've separated the REST API into the web service REST API from the front end. So a user can either create scripts and communicate with the REST API directly, or use the client-side front end, which is a React one-page application that renders the API responses. REST API communicates with the logic communicates to the MySQL server for the devices. It updates the database, or it performs the tasks like initializing configurations for the device. The final product that we've delivered to the customer is the full robust API, the dynamic React application that I previously talked about. We've also performed code handoff to the sponsor, explaining the in and outs of the code base, as well as how they can extend upon the application in the future. And we provided an on-site demo and tutorial for some of the General Electric staff. We gave them the full REST API documentation, and as well as all the endpoints for the REST API, and we gave them all our design and documentation and architecture documentation, as well as a small instruction manual on how to run and go through the application. Now for a small demo.
All right, so first, this is not our system here. This is the software running on the device. And the first thing we're going to do is just show you the default configuration of a device. So,
just because you can't see this, the device is actually connected to the laptop, just like this one.
Good point. So the first thing we're going to look at is NTP server. So Kasim will delete the one that's existing, and from our system we will define a new server and automatically upload it when the device makes contact with our system. We are also going to delete an interface called LL1. This will become more important later. We will also be recreating that interface from our system. Alright, so like a typical web app, we have the ability to create users, usernames, email, password. We also have the option to define a role for a user. At the moment, the roles are not super important. The only difference is an admin can create new users and operators cannot. We expect that in the future, these roles will be more defined and certain features will be locked out for the operator. We have added the ability to implement a second authentication method using a radius server. We will not be demoing that today because we do not have a radius server set up. So from this page, this is the SCEP settings. So we have a SCEP server running on a VM on our machine, and from this page, we would define a server. So if you might notice that we have a different setting for the system and for the device. It's possible when these are connected in the field, they may see the SCEP server from a different address. So we give the user the ability to define an address from the server's perspective as well as the perspective of the device. So now Kasim is going to add a device to the system. Before a device can be configured or issued a certificate, our user has to make our system aware of that device. This is in part of the security thing, so that invalid or unauthenticated devices cannot register with our system.
One thing that I want to bring to your attention is you can import from a file. So if you have a large list of devices, you can import all of their information at a time instead of manually having to add each one.
And we may need some devices to use SCAP and some may not, so we have an option to uncheck that if we need to.
And the serial number he has entered is actually the serial number listed on the device. That the device will send that serial number to our system so it knows what device has been connected.
Now, Qasim is going to create a device group. Device groups will contain the devices that we just added based on the criteria that we specify. You can pick any of the criteria that's shown right here in the list. Right now, Qasim is going to choose model number, and I believe our device has ECR as its model.
I just entered that when I created the device.
So now the two devices that we created just now will be added to the device group because that's the ones that are matching the criteria. Now, parameters, as we previously mentioned, is something we can think of as user-selected variables. So whichever parameter you put in right here, you put in the value or you put in a range of values, and they will be assigned dynamically when you're assigning a template configuration.
So the specific type of parameter that he's choosing right now is dynamic IP. And basically what that will do is it will actually look into the device, pull an IP address out of it, and then combine it with the value that we've given here, and then that will create a final IP address, and that'll be put elsewhere on the device. That's what's going to be set for the loopback address that Brian mentioned earlier. So now he's going to create a template. The way you would basically do this is you would go through a full manual configuration of one device, and then you would download its configuration file, and then you can take it, paste it into here, replace any values that you want to be dynamically changed or assigned with basically Jinja tags, and then those will be, it will use this file to build actual configuration files, and then that's where it'll get sent to devices. So you can see here he's basically just filling in
where the dynamic values are going to be.
So as you can see, we're configuring the NTP server here, and I'm using this parameter.
Which is
and if you look over here, the value is 1.1.1.1. So once the device receives the configuration, it should have NTP server with that IP, 1.1.1.1. And for the dynamic, it's the same, but the last two octets are going to be replaced. So the first part of the new interface LO1 that we're going to create, it should have 1.1 as the IP.
So now what he's going to do is assign the actual template to a device group. Basically what this says is that any device that falls into the device group here, this is the template that should be rendered to be sent to the device.
Okay. So now what would typically happen is the device would be connected to the network, it would reach out to our system would recognize it and begin certification and configuration. We're just going to manually initiate that process because it takes a little bit of time to disconnect the device from the network, plug it back in. So Qasim will do that right now.
So we're restarting the ZTP service, which will talk to our application.
Okay, so now
Can you show the tasks?
Yep. So before we show this, there should be a task in there.
So you can see that the device is trying to obtain the certificate. Now this is a lengthy process, so if you want to show the IDE to see what's going on in the background.
Yeah.
Also, we understand that our project requires a lot of background domain knowledge, so if you have any questions, this would be a good time to ask.
And we also have a run mount, so whatever you just did, it should be listed over here.
So that is a security certificate server. So it's a Windows server. Basically, the device will reach out to it. A bunch of encryption happens, and then the device is sent basically a private key to communicate with the rest of the network.
Any other questions?
So right now, the whole SCEP device interaction is primarily a device to the server. So what our system does is it really just initiates that process. It will, our system will reach out to the SCEP server, get a one-time password, send that to the device, and the device will actually take care of enrolling itself with the certificate server.
It looks like we're having an issue with the SCEP server, so I'm going to try to add a new device without the SCEP server, and you should still see the NTP server and LO1 in there.
So while he's doing that, how much of this process was already created for you guys versus how much did you actually have to build here?
So the actual communication with the device is the only thing that had a library. So we basically created the entire web server, all of the logic to upload templates, pretty much anything you see on the actual web application we created.
But the GU's website, that's provided.
Yeah, that's actually running on the device itself. So that's part of their software.
Where is the web service
It will be hosted on individual company networks. So there basically won't be one main location for it. It'll be as needed basis.
It would have to be though running on the same network as the devices are on. But the front end and the back end are separated, so the back end can really be running anywhere, and the user is still available from any other connected system as well as the devices.
How are the templates being stored?
They're just stored on the web server itself, and it uses Jinja to just register the different variables into it.
So we're not really sending them data per se, we're sending them configuration files. So this isn't something that we've had to be concerned about because it'll be up to the user to identify what kind of interfaces are valid for the device. So I imagine there's a possibility for some of the interfaces that we were creating, maybe create too many, but it's kind of up to the user to decide where those limitations are because so the GE orbit line, it's not just this particular product. There could be several products, so it's absolutely possible that this product has features another one doesn't. So that would definitely rely a lot on the user to validate that their settings are correct for the device.
Do you have to worry about security
Yes, somewhat. We don't really worry about device security so much, but we do, obviously, we have an authentication system in place. So, yeah, somewhat.
Yeah, so from a security standpoint, it wasn't really in the scope for us to so much protect, the network's going to have to be protected on the user side. So if somebody's watching data come through, it's possible they could get it. But the communication with the device is already a secure library, secure connection. So we're not too worried about that information being taken. There was some concern that a device could register with the system that's not the actual device, right? Because the only thing our system needs is an IP address, doesn't matter from what device, and a serial number. So if a malicious device were to attempt to access our system using the serial number from the actual device, it could get the configuration file. However, that's supposed to be where the SCEP server comes in. If the device has not been certified with the client's SCEP server, it can't get the configuration file. However,
You have one more conclusion slide that you may want to wrap up with?
this was it.
Okay. We can continue on with questions then.
So what are some of the biggest challenges you faced besides this one?
I think understanding what we were actually building was probably one of our biggest challenges. Obviously, we've learned quite a bit. We've had to learn quite a bit about networking and kind of what a SCEP server is, what configuration files we're trying to build, all that kind of stuff.
I think you guys said you did an on-site testing of your product. Like, what were you trying to get out of it, and what did you actually get out of it?
We were referring to the on-site demo and tutorial. We were just showing the GE staff how they can use the product to configure devices.
Yeah, it looks like our demo is not working.
Well, you took this.
I think it's the SCEP server.
So, is there documentation for somebody that's running through this process to look at, or is it kind of built in, a plan to be built into the web server itself?
That's something that is not currently built. We did kind of design for a system admin type of user, so somebody who actually knows what all of these things mean, because they'd be doing it manually anyways. But yeah, that is probably documentation that would need to be built before it's actually sent out to the customer.
Let's thank the team.
We're Team Web Apps. I'm Christian Greaves.
Michael Alfonzetti.
Farala Serrani. And Adrian Cruzat.
And our advisor was Professor Hawker, and we are working for Wegmans. So quick overview of our agenda. We're going to tell you what our project is. We're going to show you which technologies we ended up using, and both software and hardware. We're going to give you some architecture and wireframe slides. We're going to show you a demonstration of our application, and then some final metrics, reflection, and wrap up, and then a little bit of what's to come, and then anything else. So our task was to create a task management system with a focus on prepared foods auditing. This would be for compliance with what Wegmans calls HACCP. So we'll get into what HACCP is in a moment. The application should do three things. It should allow employees to actively monitor a food product and when it needs to be audited next. It should allow an employee to perform what's called a corrective action on a product that falls out of compliance. And all of this data on the application running on an Android device should be able to be synchronized with all the other applications running on other devices within a store.
So what is HACCP? HACCP is a preventive approach at handling food. It concerns mostly on checking on the food and taking critical control point measurements during the lifespan of that food. Here in this diagram, we have a couple of the flows in the Wegmans process. Our application falls precisely where measurements need to be taken on products that are out there. We need to control them and every so often require the user to take those temperatures and measurements.
So some of the technology we used in this app, we were actually handed a lot of this technology by Wegmans, so we were required to use an Android device. We deployed devices that run Android 7. We use Xamarin 3. We originally used an old version of Xamarin, but we upgraded to 3.0 because while it shares the cross-platform support, it's fully native with Android. It also supports our database. And with 3.0, they actually introduced CSS styling. And then we were required to use the .NET framework and C# and follow basic Microsoft standards. So Realm is our database. It is a NoSQL open source cross-platform. It's designed to integrate very, very nicely with Xamarin. It's free and well documented. It's easy to use, and it was very mobile friendly and lightweight. And then our hardware was just a handheld Android 7 device, and it has an integrated barcode scanner. And it interacts with a Bluetooth thermometer device.
So, before we go into some of our wireframes and our demo of our application, this is basically the architecture and the data model of our project. As Michael mentioned before, we're using a NoSQL database. This is object-oriented, so it maps the objects that we create into objects within the database. This is essentially all the objects that we're taking track of within our application. Some of the important highlights here, we have what we call schedules. This is what we controls the task management of things that need to be controlled. A schedule would be, for example, you need to do this every 2 hours, every 3 hours, do it once every hour, and then be done with it. Those schedules contain units. Units are things that take measurements. For example, a case of cheese out there in the floor would be something that would measure every 2 hours, for example. We need to take a measurement on this unit. A couple important architectural decisions we had to take as the team. We had to create what we call a time reportable interface. This allows us to wrap our objects into objects that we can present into the front end. This allows us to have an object that is not continuously reading into the database, but it's a snapshot of the moment when we created that wrap around that object. It allows for a bit more optimization. Another critical decision that we did with our architecture, and this is because of the limitations we found with the database that we were using, we had to use a strategy pattern to handle units that were similar, but we couldn't use inheritance within our database. So instead we had to extrapolate those as essentially strategy names that each unit can be configured to use. And when the application is run live, the unit knows to call exactly which strategy you need to use to perform the configured way to handle things.
So these are just some of the wireframes we put together. These were put back together way back in February. Wegmans really emphasized that they wanted a very smooth and clean front end. So we actually made these wireframes in a professional program. If we actually had it up, you would actually be able to click and walk through the entire application just on the wireframe side. So you could actually see, you know, what happens when I click one button, what happens when I click another.
So using the wireframes as a starting point, we made the application. Let me back out of here and hopefully be able to look at our phone. So here it is plugged straight in. And here's our application. So this is the login area. Ideally, we would be communicating with a Wegmans server, their employee server, to be able to actually log in as an employee. But we don't have that functionality because the backend didn't support it yet. So right now, we're sort of just mocking it. The Repopulate Database button is for us so that we can quickly refresh the database and see what we need to see as we're walking through the application. So let me log in as user 123. So when I sign in, it brings me to store 1, which is where I am. At the top, there's my username. If I click it, it'll let me log out, but I'm not going to log out because I have to show you. I'm going to click on Department Old World Cheese within Store 1. This is where you go and buy your cheese at Wegmans. So Old World Cheese has a cold holding schedule. This is the schedule on which the cheese cases are measured to maintain temperature compliance. If the temperature falls out of a range for a certain amount of time, in this case, once every 4 hours, it has to maintain this temperature of 41 degrees. If it's hotter than that, you have to perform what's called a corrective action. So let's take a look. If I click on the schedule, it brings me to a unit list of units within that schedule. In this case, we've got one called Barcode Product, but it would realistically be case 1 through N. If I click on the Barcode Product, it brings me to the details page for this. This is where measurements are stored. As you can see, things are being color-coded throughout. So here we have a green, which means that we still have a long time to finish. Currently, we've got it set up so that when it's above an hour remaining in the schedule, it's green. If it's below an hour, it turns yellow. If it's below half an hour, it turns red. And when it's deactivated, like out here, you can see that it's gray, so it doesn't really matter. The reason why that one's deactivated is because there's nothing in it. So if I go back in, I'm going to be able to take a measurement. When I take a measurement, it brings me to a barcode scanning page. Now, I had a barcode on my demonstration, but the demonstration, or the presentation, sorry, but the presentation is a bit awkward right now with the strange scaling. So instead, we've got a barcode here. And when I click scan, as some of you might be able to see it, there's like a laser that comes out of, I don't want to shine it in your eyes. When I scan it, it detects the barcode number is registered, it's red. I'm able to either scan again, or I can confirm the product. If I confirm the product, it brings me to the temperature probe integration. Now, most of this would be separated out into multiple flows, but for the time that we had, we were only able to do one flow. In this case, we are going to scan for Bluetooth devices. We're going to connect to the Bluetooth device, specifically probe devices, only probe devices. We're going to obtain measurements to be able to see what the temperature probe is reporting, and then we're going to submit it as a temperature. So if I click scan, it will scan for a couple seconds and then show me a little notification that says one device was found because this device is on. I can connect to the device. You'll see the device flash to confirm that a connection has occurred. And if I click obtain measurements, it should update that no connection to a temperature. So currently it's reporting 43.8, 3.7. This number doesn't update unless you click here, but the actual number that is being reported is live based on the probe. So if I was to click, if I was to keep squeezing it, you can see it still says 76, but if I click submit temp, it updates it to 80.6, because that's what I'm squeezing the probe at. Now 80.6 is way above 41, so you have to perform what's called a corrective action. If I confirm the corrective action, it gives you a list of relevant corrective actions based on this product. In this case for cheese, we have to discard it, so we're just going to chuck it out. So we select the corrective action, we then submit corrective actions, and you can choose as many corrective actions as you want from that list. This page would display to you all the corrective actions that were shown. We confirm the corrective actions, and it registers that a measurement was taken at that temperature, and in the data of that measurement is a corrective action that has been applied. Not all measurements have corrective actions, but when they do, it's there and can be seen in the database. So there's a sort of an audit trail that you can take through the stuff. And the time is reset to about a minute ago when I took the initial measurement. That is the time the measurement was taken was about a minute ago. So the time is updated to the schedule. We go back out, we see the schedule time is exactly the same. Oh, this is the unit time, sorry, but if we go back out again, the schedule time is exactly the same. It's working off of that first measurement, the top measurement in the top unit of that schedule. So let's show you the Asian bar now. So I updated this about an hour ago, well, an hour and a half ago, and as you can see, hot holding is nearing completion. It's turned yellow, we have 30 minutes left. If I was to sit here for another 13 seconds, it should turn red. So let's do that for a sec. So Asian has a couple of features. So there's two buttons at the top here. There's add cook log item and add pH item. Add pH item would be a part of the sushi department, but we've sort of crammed things together into one department just for the sake of showing. So as you can see, it's turned red because it's ticked below 30 minutes. And there's two other schedules below it. We have 4-hour cooling and 2-hour cooling. Those don't have anything in them, so they're gray right now. So let's add a cook log item while we're here. Adding a cook log item shows us multiple recipes that we can cook in the back area of the Asian before it's brought out to the hot bar. Like when you go to Wegmans and you see all the sushi on the bar. Or not sushi, sorry, all like the sesame chicken and General Tso's or vegetable lo mein. So let's cook some General Tso's chicken. General Tso's chicken has to be cooked to a temperature of, I think it's 165, but we're going to say 180 to be safe. And we're going to make 5 pieces of it. Pieces could be actual chickens, they could be chicken legs, they could be pounds of chicken if you're making a whole recipe of General Tso's. For the moment, it's just a pound of chicken. So we made 5 whole pounds of General Tso's chicken. It was logged at that timestamp, which is now, it should be now GMT. If I click Submit Details, it brings us to a distribution page. Now this distribution page currently is sending all 5 pounds or 5 pieces to one of these 2 schedules. The reason the third schedule is in there, the 4-hour cooling, is because the 4-hour cooling schedule is dependent on the 2-hour cooling schedule. It cannot be pushed to by itself. Things from 2-hour cooling go into 4-hour cooling. That's it. So we have a choice between the two. Or we could split it. So we're going to split it and put pieces of it in each schedule. We're going to put 2 pounds in hot holding, and we're going to put 3 pounds in 2-hour cooling. If I was to type in a number that doesn't add up to 5, it would say, nope, do it properly. But I'm not going to do that at the time. So submit distribution. It creates what's called a cook log transaction. This is a document, an object stored in the database that is comprised of information pertaining to this transaction. In this case, it's what was cooked, General Tso's chicken, the time it was stamped at, which is what that big number is there in Unix time, milliseconds, and the other ones are things like temperature and which schedules it went to. So if I click Return to Schedule Summary, it can see that 2-hour cooling now has a thing in it. If I click on that, the thing, General Tso's chicken, has been updated. If I took a measurement, it would be the same process as before. But I'm going to take hot holding. So we have 2 hot bars, hot bar 0 and 1. If I take hot bar 0, I can take a measurement. And this time, it gives me what was cooked in a pick list. Things that have been cooked get sent to this pick list. And I can select it here. It would present me with a Bluetooth scan bar for time. I'm not going to do that. Instead, I'm going to give it this developer menu, which allows us to type in an actual temperature. I'm going to select 180. If I confirm the measurement, it logs the measurement, resets the time. It resorts based on most relevant time. And then this doesn't update. I don't have time. If this doesn't update, because the top one is more relevant, it's more contextually relevant than the one. If I was to measure the other one, it would also move to the bottom, and then this would resort below. And that's all I have time to show you. There's a lot of more stuff in here, but we don't have time. So back to the presentation. I hope. I'm not touching anything.
Okay. So, with the presentation, a quick demo of what we had. There's, as Chris mentioned, there's a lot of workflows that we haven't gone through. So let's go into some of the details that went into our process. First up, let's talk about testing. As for unit tests, we wrote our unit tests on using this XUnit framework. We wrote some of our tests. However, we did find a major hurdle while we were implementing them. We found some incompatibilities between the dependencies that we had on our Android project and the dependencies on the test project itself. So we had some complications while doing those tests. Other than that, we had a lot of end user testing. as we talked in our interim presentation, we meet with the Wegmans team every week. Every week we're presenting them an updated product of the progress that we're making with the product. And during those meetings, we get their feedback. We tell them what we think, what we found, what is hard, what is not, what is working, what isn't. And from there, we refine what we have, and from there we can keep looking forward to what we're going to be doing next. Finally, we have a couple of test metrics that we keep track on our Visual Studio server. Some of the metrics that we have, we've been keeping track of our requirements as user stories. We've been keeping track of average user stories point completed per iteration. We've also have a graph that shows us how much work we're taking in and how much work we're completing. This is a quick graph of our average, a graph of the story points that we completed per iteration. Our iterations were 2-week longs. The takeaway from this graph is not the actual points, it's to see essentially the average of how we were working. You can see at the beginning there was some learning. There was our first development iteration coincided with spring break, so we just took very minimal amount of feature times that we could use. And then as you can see, we remained consistent until like around almost the end. It was around the 4th of July. Again, our consistency went down a bit, but then again we spiked a bit and we continue working on that. The second graph, quickly, on the light blue, it shows the cumulative work that's been accepted as we go through the project. And as you can see, the dark blue and the dark green, it pinches it up as we start marking that work as completed and done.
Okay, for project reflections, we'd like to touch on 3 things: hardware, software, and the process. For hardware, we had two major connection points. One for the barcode scanner, and the other one is for the temperature probe that you have seen the demo for that. We were at a stage of our development iteration. We were provided with an SDK that only works for either Java Android or Xamarin.Android, where we are building in Xamarin.Forms. And this is where we had difficulties writing to prop-ups for these developments into our current development. For software, we worked with the Visual Studio, even though that is powerful enough to do lots of things. However, downside is that work with Visual Studios through multiple development environments gave us lots of trouble. Xamarin Forms was a great framework that we worked with, and C# when we started the project back in January, we didn't have any experience with C#, but we were able to pick things up fairly quickly. And for the process, we had, as we have mentioned before, that we had 2 weeks iteration, and we did almost 10 iterations. The takeaway that we might want to do is that to enhance our communication, perhaps if we were provided with the Slack channel between us and the sponsor, that might have improved our communication. Reflection for goals and accomplishments as well. We successfully completed all the 6 workflows that we were asked to do, and we were successfully integrated the hardware connection points, and for our design, we make it we made our solution that it is more at an abstract level where it can be a task management for basically anything that Wegmans wanted to use. We also missed the synchronizing the data with the remote database, and also the connecting our current application with Wegmans systems, and that due to the lack of infrastructure that Wegmans had in their end. Finally, we did a code freeze by August 1st, and by that time we spent a good 13 hours where we documented all of our code, of all of our source code. We went line by line, commenting and commenting things that Wegmans might want to know, and we generated a list of to-dos for them, as well as we removed the unneeded until branches. All diagrams are being either given or will be given to Wegmans very soon.
So, any questions? That was a lot, I know.
Yeah, what's up?
So in your workflow, when you were selecting a Bluetooth device, what do you do if there's multiple devices?
So, again, we didn't get too far into this. The idea was we wanted a proof of concept that we could connect to the Bluetooth device, and it actually ended up being harder than we expected. We spent a good 3-4 weeks trying to get it to work.
3 iterations in total, so 6 weeks actually, from research to actually getting it in the state it's at now. We were only given one at the start, so initially we thought we wanted a list to be able to pick from to choose which one, but right now it just chooses the first one it finds, and it always finds one because we only have one. So, but it uses a proprietary SDK for this company's device, and so it only finds this company's device. If we had multiple Bluetooth things around, it wouldn't find them. Anything else?
Let's thank the team.
So we have a bit.
All right, everyone. You know this is the last presentation, so we'll try to get through this quickly. I'm Thomas Faticone.
I'm Scott Barron.
Quentin Goyert.
Dylan Ho.
And we are Team Orion. For the last 2 semesters, we are tasked with working on the STARS check-in system sponsored by STARS. So in this presentation, we will be going over the background, some requirements, how we got those requirements, the product, a description of the system, the architecture, a vision for the future, a demo video, and then a review. So who is STARS? On STARS' website, they describe themselves as STARS has been developing, delivering, and supporting housing software solutions to higher education for over 25 years. So what does this mean? So this means they do bed management, which is they just assign people to specific beds. They do roommate agreements, roommate selections. They even do conferencing. In addition, it is important to note that this is an international company. So they service well over 100 countries and 3 million students. So when STARS came to us, they came to us with the idea that we needed to create a prototype, one that's fast and efficient and removes these bottlenecks that currently are present in check-in day systems. In addition, it has to accommodate a magnitude of students. Now, just as a reminder, they service over 3 million students in over 100 different countries, meaning the solution is going to have to be different. It's going to have to worry about localization. And specifically, they pointed out it's going to have to worry, or it's going to have to be concerned with accessibility. So that means people with impairments have to be taken into account when we design this system. They also wanted us to take into account different check-in day procedures, so that whether that means the ordering or the technologies used to actually check in students to dorms, we need to be able to accommodate those types of situations. And lastly, they want us to revolutionize the check-in system by introducing new technology. We ended up accomplishing geofencing, or geolocation, but in addition, they also kind of pulled the idea of facial recognition technologies, QR systems, and other things that would definitely make the system a little bit faster. So, let me set the scene for you guys. Remember your first day on campus, your freshman check-in day. And yes, I know a few of you that might be 30 years ago or plus, but just bear with me on this one. It was very stressful. You got to campus, you were just told to go to one place, all the students were corralled around with their parents. Your parents didn't know what to do. Your student didn't know what to do, and on top of that, everything was just chaos. You had to attend these events that you really didn't want to go to, but you knew you had to make friends because that was the cool thing to do. But in the end, it was a very stressful process. So our goal was to make that a little bit better for everyone. So we interviewed a few universities, specifically 3, and we came up with some common issues. So one of the biggest ones was these manual processes could be easily replaced with automated ones, thereby saving time and headaches. And next one was participation in moving day events are at a low. And I know a lot of you might be like, why does that even matter? But in the end, these are extremely important for making your friend groups, your initial friends that will either make your first year at university great or bad. They also wanted instant communication between the students and the housing committees. Whether that meant it was just like a weather event or last minute housing change, they wanted an easier way to do that. And even so much that, I don't know if you guys know this, but in New York, if there's lightning, all housing operations need to cease. So there needs to be a good way of communicating such an event to the students. In addition, they wanted to deal with traffic flow issues. Such issues are actually reverberated with many universities. We even had one university complaining about a complete traffic deadlock because of a sporting event, which is a very lose-lose situation for everyone involved. And lastly, they wanted to keep track of borrowed items, whether they were a cart or a helper, to make sure that they weren't kept out for too long or lost in the process.
So, our requirements were based on our interviews with the universities, our personal accounts, feedback from the sponsors, and the initial problem statement. So, vague overview of some of the more important requirements is that the user is able to go through the automated check-in process while being told where to go, such as to pick up their key, to where they need to park, where their dorm is. When in the unpacking stage, they'll be able to request a cart or a helper with the click of a button. And the application can show policies, instructions, and other important information that needs to be known. So our solution included quite a few features. Some of the main features were the geolocation-based check-in system, which guides the user through the check-in process. We also added an admin panel to customize the app experience for each university's needs. Problems that were solved were that the navigation assistance helps to direct the users where they need to go, including to and from waiting areas, which helps to mitigate the traffic flow issues and also helps to lower the general confusion. In addition, our events page helps the users to keep track of those welcome events that can be so often forgotten in the rush of the check-in process. It's even showing when they are required and when they are not.
So on the back-end side of things, we have the StarRes web services, which were already exist. They were given to us by StarRes. We use that to verify that a student exists within the university's database, to get their room assignments, and then ultimately change the status to the showing that they're checked in. And then we have the admin panel, which is also on the back end, which is how the admin customizes and tailors the university's check-in process. The back-end API also hosts the real-time socket server, which is what is used on the student-facing side for the real-time communication channels. Oh, and then the front-end client is what walks the student through the check-in panels. So the student, no. Oh, yeah. So the student, no, this is the student-facing architecture is a componentized process. This makes sense for us because we broke the process out into steps and then built the component for that step. And with adaptable routes with Vue and Vue Router, we're able to customize the steps, or the order of the steps that they come in for the universities, so that if RIT's process or the order for picking up the key is different versus U of R's, our application can be adapted to the university's process without any extra overhead. The real-time queue service is connected from a direct component, and that gives us the real-time messaging channels for university services, such as the finding the helpers, or getting helpers and support through the check-in process. And then the front-end application is designed mobile first, and any of you guys that have done mobile first design knows that when you change the zoom and you change a slight little thing, your entire UI can go crazy. So that was one of our pitfalls. We brought in Cordova configuration, which gave us the versatile deployment we needed. So with Cordova, we were able to get a traditional server-client architecture set up for the two parts of the product, or Cordova can build the application into iOS and Android and then distribute it through the respective stores. With Cordova, we had a couple of dependency issues. Certain packages needed secondary compatibility packages, or just purely were not compatible. And then permissions, because of the different levels of operating system and even brands, the permission levels can be different from device to device, even though it's running the same application. So Cordova does a pretty decent job at doing it, but we did fall into some pitfalls with that. Our back-end API is a RESTful architecture to handle the data creation and the handoff of the data to the student and admin clients. The check-in database is our database for the project. We use to maintain data that does not currently exist on StarRes's data model. Our socket server handles the real-time logic and operations for the university's queue services. Because of other choices in our tech stack, the integration of the socket, this is one of those compatibility ones where we needed to get secondary packages to get working with the project. And then the admin panel is just a single page view application, and it's modeled after Google Chrome's setting page, so anyone that's been in that, and we'll see that coming up. And that was designed so it can scale with the future features of student check-in. And then our overall architecture, we used Heroku dynos to host our development environment. We've got one for the back-end and admin client database, and then another one which is the student check-in client. So for our dev environment was a client-server setup, but Cordova could have done the package builds.
Pros and cons with Heroku, we got continuous integration, which was awesome. We were able to build see the results of our build in less than 5 minutes, which led to rapid deployment, and then easy Postgres integration on the back end was also a huge pro for us. Now, the pitfalls of using Heroku was, again, configuration, especially with Webpack and how it likes to minify and build your projects. We had some configuration pitfalls with that, where, again, secondary packages were brought in to make it work. And then the configuration of build scripts, we had some unforeseen stuff that we had to work through with that, just steps in the Heroku build process that we didn't see right off the bat.
So during the development of the project, we had envisioned a number of features that didn't make it out of the design phase, or did make it out of the design phase but had to be dropped due to time constraints and development constraints. So while all the different kind of pages and functions were kind of compartmentalized as mentioned earlier, we did not actually develop out the system for properly rearranging them for the order based on universities. So if a university needed you to do a key pickup or a personal check-in before everything else, there was plans for that, but it has not yet been developed. On top of that, we also had designs for how universities wanted to handle check-in, such as if they wanted to do it through a QR scanner on like doors or at certain areas, if they wanted to do it by the location-based system we've mentioned, or if they wanted to do it through other methods, such as a administrative user actually hits a button on a person's name and checks them in. On top of that, we also wanted to develop a alert or messaging system that would send out notices due to, say, inclement weather, due to last-minute changes, or perhaps just notifying certain users of certain things, such as staff helpers that are running around helping people to go to certain key areas. We also, for the goals we didn't finish, of course, a QR-based check-in system. We had developed the ability to scan QR stuff, but the feature turned out to be a little too difficult for the time we had, and had to ultimately be dropped from the final release of the system.
Alright, so now we actually have a demo video. This is a little bit non-standard, but the reason why we chose to do a video instead of a traditional demo is because a lot of our technology uses geolocation, so what you would end up seeing is like half the time is our application, and then the other half is us messing with a location spoofer, just to show you that to prevent it from moving forward in our process when we didn't intend it to, or to move it forward when we actually meant it.
So this is, we're going to open up onto the admin panel. Clicking register university, this is the entry point for universities creating. Right here, we're highlighting the StarRes database domain. This is for universities that already have existing StarRes databases. That's how we are able to connect and link our database services. Now we're going through filling out, creating a new admin user. We're using a join code, RIT18. That's how we link universities together, or that's how a new user would get linked to an already existing university. Now creating the user, we can see the data. So again, this was an existing university. Settings menu is pulled over on the side as well. But we're seeing the data that was already existing in the database mapped with the university, and going through creating an event. Yeah, so this page again resembles the Google settings page, Chrome settings page. And we just felt that that was the simplest and quickest design to go with. And then adding the event, users prompt with a modal, and then
And then this is our applications. This is what's going to welcome you. It's just a standard login page. This is my spoof data. Please don't copy it. So once we log in, you'll be greeted with the home page. These are StarRes colors. We went with a simple yet very informative design. And the first page we'll go to is the events page. So the events page is where you can see your welcome day events. Just a simple interface. Heading back to the page, we can go to the gallery. So the gallery is this page where Universities show really important information, just like procedures or watch-outs. So when we can start the process by clicking this green button, and you'll be told to go to a holding lot. This is just to make sure that no one that is needing to get a key is like in the way or causing traffic problems. But once you're there, you get placed into a key queue. This is just to ensure that there's not too many people trying to get their keys at once. Once you reach 0, you're informed to go to the specific location to go pick up your key. Once you have it, you get placed into an unpacking queue. Same thing as before. Just make sure that there's not any crowding. Once you hit 0, this will bring you to the actual the place where you're supposed to go. This is geolocation based, so once you get there, then you'll be introduced to the unpacking page, which is this. This is where you can request carts or helpers. There's instructions. They'll give you statuses on what they are. So once you're finished unpacking, you get told to move out of the way, go to a holding lot. This is where your car will stay for the rest of the journey. Once you get there, you get told to go back to your dorm, finish unpacking. There's also areas of interest, just in case you want to see some things. Just to make sure that you've completed everything in the check-in process. Here's a little next page that we decided to add in. And then finally, you've completed the check-in process. So, just a short review. So, STAR has wanted us to create a prototype that attempts to solve issues of efficiency, whether that be automating a process that was meant to be, or that was initially manual, or provide just clear instructions so that there isn't any issues with bottlenecks.
It included many innovative features, such as the automatic check-in based on the geolocation system, and the queue system that is connected by sockets to provide real-time updates.
Our design choices with the application enabled us to create a configurable process for the universities to use.
And for the future, our intentions would be to fully implement the QR system, proper ability to reorganize pages, and then finalize the database hookups to their main server system for the general information communications between our app and all their university data.
Any questions?
Did you perform any load testing, or was there any architectural considerations for thousands of concurrent users?
I'd say probably not, but that was because we intended this to be a prototype, so it was going to be a very limited amount of use. But in the future, of course, if this is going to be used on a production, we would start doing load testing.
This is also an application that a university could host itself for their student body, or StarRes could host in the cloud for a university. So it's versatile hosting options with the application.
From what I can tell, it seems like there's a lot of requirements in the initial project idea from StarRes to you guys. So I'm wondering, like, can you estimate what percentage of the requirements that you actually agreed upon doing? It seems like there's so much.
You're right. We ended up, because like what we were given just like, we want you to do a check-in system. And then when we did interviews, we had all these ideas, but we just decided to flatten it out. So probably, I would say safely 40%, would you say?
Yeah, I would say we covered about 40% of the ideas we came up with.
The very like minute list we actually came up with, and this is just the accepted, what we accepted.
Yeah, it just seems to be like having all those universities in one system, just like
Quick question. So, you guys have sometimes show the maps where when you're like, when you get to a certain place, then your app shows the maps. Can you interact with it, like move around? And,
yeah, it's just a typical Google Maps, but just so you can move around, you can just see, zoom out, zoom in, typical things.
And our styling didn't really make it look that way, but it was.
Cool.
Did you
implement push notifications and stuff like that, or do you have to actually be looking at the app like the queue takes down?
So the Cordova configurations and stuff, push notifications would come from that. And long story short, no. And it was all just time issues and then Cordova configurations. And so we decided to push that and not include that in our scope. But it was thought of.
All right, let's thank the team.